Okay, we are going to discuss about data warehouses. After looking at properties of data like views of data, and then we looking at the analytics of data, sources of data. Now we are going to look at how are we the analytics part, the modeling part of a descriptive analytics, which is the data warehouse. So if we start, what is the data warehouse? So data warehouse is a can define in this way. It's a comprehensive technology, meaning it's not just a database. It can be, it is combination of multiple technologies, such as you extract data from sources, then you transform to your need, and then you store in your database, and then you do the reporting, cubes, analytics, what if analysis, all sort of stuff. So it's not only about story, it's a comprehensive technology. And then that provides key people. Who are the key people in an organization? So key people are people who take strategical decisions. In an organization, everyone take decisions. But data warehouse predominantly looking the targeting for the people who take strategical decisions. And then enterprise-wide access to any level of required information. So in an organization, there are different levels of information. For example, I can analyze data for region-wise. Then I can go into the country-wise, district-wise, the area-wise. So I can go into, I should have the option to go into any level of information. And it's a framework, enterprise-wide framework. What do you mean by a framework? Framework is when it comes to a framework, you give a framework to people so they can do their own work. In the development environment, we have .NET framework. So .NET framework, what it does is, the developers can use the framework and do their own UI, mobile applications, web applications, depending on their need. So remember, in data warehousing, we are not building a one report. We are building a framework. So that users can, by using the data warehouse, they can do their own report. For example, I can use a data warehouse and analyze customer-wise sales. Similarly, another person can analyze region-wise sales using the same data warehouse. So as a data warehouse, data modeling people, we are not going to give a one report. We are giving a framework. So that depending on your need, you can run your own report, run your own analysis and get the required data. And finally, it's a management of all enterprise information. If you look at sources of data, which we discussed last time, we have different information coming in. There's some are external, some are internal, some are structured, some are unstructured, all are data. So in data warehouse, we combine all this information. So when it comes to this definition of data warehouse, remember these 5 terms: comprehensive technology, key people, any level of required information, enterprise-wide framework, management of all enterprise information. So first one is a more business-oriented definition, I would say. The second one is a technical definition. That is, it's a collection of decision support technologies aimed at enabling the knowledge worker, that is executive, manager, analysis, to make better and fast decisions. So remember, we need to make better decisions as well as faster decisions. So I prefer the first definition because it's a more relevant. It's a practical and business-centric definition. So this would be a traditional data warehouse. So you can see you are getting the data sources from different sources, operational data. And then we will be we have the defined data warehouse. So we have to take the data from sources to the data warehouse through ETL tools. We will be looking at ETL tools little later. ETL stands for extract, transform, and load. Once data is loaded into the data warehouse, then different types of analytics can be made. You can see, you can run reports, you can do data mining, OLAP analytics, and what-if analysis. So in this, so you can see the comprehensive technology. It's not just a database. There are ETL components, there are reporting components, data warehousing components, and all of the technical knowledge as well as tactical and practical knowledge is very much needed in data warehouse. I would say the most difficult part of a data warehouse design, the data warehouse is designing it and the ETL part. This is little traditional or legacy data warehouse, but nowadays you get data from everywhere. It's not just structural data. You get data from mobile phones, you get the chats, whether the phone recording, emails, images. So you have everything in as form of data. Right. Now you may have a question, why we need another environment for data warehouse? You are familiar with operational databases. You are familiar with designing an operational databases, but why can't we use existing environment for this analytical purpose? So remember last time we said descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. Next question is, why we can't use existing databases for the descriptive analytics? Why we need a separate environment? As and when you go for separate environment, you will have more problems. You need to maintain it, design it, extra hardware, cost, labor. So why can't we use existing operational database for the instead of a data warehouse? These are the reasons. If you look at operational databases, they are mainly to run daily business operations. They are just to run daily basis business operations. They are looking at how many sales were done, how many employees were in the office today. When in a hospital, how many patients in-house? How can we issue a bill? But data warehouse, it's looking at analysis and decision making. What happened? How many patients from last year to this year? So a lot of analytics will be there. So when it comes to operational databases, decisions are operational and tactical, day-to-day decisions. In data warehouse, we are looking at strategical and analytical decisions. For example, strategical decisions means, for example, I want to set up a new supermarket store. That's a strategical decision. So I want to close one supermarket. That's again a strategical decision. When it comes to operational databases, it's short term and looking at the current state. You are not looking at how much sales happened 5 years ago. But data warehouses, you are looking at long-term trends. Medium, we could say medium as well. Data nature, you are looking at the current data. Now, for example, sometimes employees will change their nature. For example, if I'm an employee, I would be, I'm not the same employee who joined 4 years ago to the university. My parameters have changed. I have gained knowledge, experience. So how you would analyze that how you would take that consideration into your analytics? Then users. So typically when it comes to operational database, we are looking at people like clerks, application and frontline staff. Again, I'm not discriminating in their jobs. Those are the people who are frontiering to the operational databases. They're people who are doing the day-to-day operations. But data warehouses, it's managers, analysis, executives who are looking at the business data warehouses. Number of users, you will have large number of users, many concurrent users that on using operational database. But in data warehouses, you don't see much users. That's an advantage you will have with the data warehouse. Operational databases are more, it's more predefined transaction. If you look at if you go to a supermarket and in a supermarket bill, you enter the date, cashier code, customer code if there are any, then you enter the product number, you get the product code, you get the quantity, unit price, amount. It's a standard. But data warehouses, it's totally ad hoc. I might start my analysis from employees today. Tomorrow I want to start from customers. Tomorrow in customers, I want to do customer category analysis, but someone else want to do some other analysis along with date parameters. It's a totally ad hoc nature. So operational databases mainly typically used for order entry, billing, and payroll purposes. Data warehouses, reporting, forecasting, and dashboard. So now earlier I was discussing the business difference between operational and data warehouses. There is a technical differences as well. What are the workload? Sometimes you might not understand these differences, but later once we do designing of data warehouses, then when you come back again, you will understand this set of comparison. Operational database, we are looking at transaction processing, order process. And when it comes to data warehouse, we are looking at the analytical processing. Operations, we are mainly CRUD operations, as you would say. Insert, update, delete. But data warehouses, you aggregate, you summarize, you read, mostly reads, but you do the aggregation and summarize. Records per request. You enter the customer code in a bill, you get one customer description, customer name. You enter the product code, you get the description for that particular product code. So few records. But data warehouses, last month versus this month, last year versus this month. So therefore, the comparison in data warehouses, you are looking at large number of records. Query complexity, transactional queries are very simple, right? You may have run SQL queries, joining couple of tables. But data warehouses, you are looking at complex and multiple table. Even in transaction also you do multiple tables, but not in this nature. Data volume, typically small in the operation. If you look at order system, in an order system, you are looking at one customer, one cashier, and maximum 100 or product codes. But in data warehouses, you are looking at last month, last year, last quarter data. Update frequency, continuously it's updated. You go to a supermarket, see how many customers are there. At a given time, there are large number of customers in the cashiers. In data warehouses, you don't do such updates. Typically, what you do is you extract data in a midnight off peak hours and transform that into the data warehouse. So therefore, it's highly volatile. Changes are happening almost. Sometimes you reverse the orders, cancel the orders in the operational systems. You issue a bill, later you do add a discount. But in data warehouse, it's non-volatile. Once it's loaded into the data warehouse, data is static. Response time, yeah, Now you can't wait in a queue. You can't wait in a queue if you are, let's say, okay, you are scanning the product code, right? Let's say your cashier is scanning a code and it takes 5 seconds, let's say. Just imagine you're keeping some object inside in front of the barcode. It takes 5 seconds. 1, 2, 3, 4, 5. Are you happy with that? Of course not. In operational database, it should happen quickly as possible. But data warehouses, that's fine. If you run a report, okay, you can wait for 5 minutes. Can wait for a couple of minutes. That's okay. Schema design, we will be discussing in detail. So in operational databases, we are looking at third level normalization at least. This is a minimum. You can go for 3.5 or 4. In data warehouses, we are looking at denormalized structures, or we call them as relaxed normalization. When it comes to operational system, it is application specific. Now you are building an application for supermarket. You are building an application for hospital. Even a hospital, you are building it for the admissions. You have a specific reason, specific process, HR process, sales process, attendance process. But for data warehouses, you integrate multiple data and produce analytics. You look at the HR data and sales data, you produce a report. So that's the difference between a data warehouse and an operational database. So this is the data warehouse structure, rather the process from Kimball, which is we say that he is the father of business intelligence. So he is the one we normally refer when it comes to data warehousing. You can see the modeling step, and it's not a one-time work, cyclic work. I can assure you, if you are into data warehouses, you are getting work every day. Why? Data warehouse needs data from multiple sources. There are instances where data warehouse is dependent on 17 sources. So let's say 10 sources, your data warehouse is dependent on 10 sources. In case there is a change in one source, you have to change your data warehouse. Right? So therefore, when it comes to data warehouse, it's a continuous design, continuous life cycle management that you need to offer. Right? What are the questions that are asked from data warehouses? What products are more popular among 15-year-old females? Products and customers. You are linking. Sales. You have sales. You are linking with customers who are between these ages and females. And products. Order lead times. On-time delivery percentage to a particular customer. Comparing all the customers. So you are looking at this, your delivery operations along with from the customer perspective. Cost and hours spent by a patient by ward. Percentage of projects is stuck in a contracting phase for more than 10 days. What are the percentage? So you can see it's not simple linear analysis that you do. It's a comprehensive analysis that you do, complex analysis that you do, integrating multiple different sources. Okay, this is the classical example from Ralph Kimball again. Now, his comparison between operation systems versus data warehouses. So he's saying operational systems are rotating the wheels. Data warehouses are observing, measuring, and analyzing how the wheels rotate. Now, if I ask you, what is more important? What is more important? The more important part is no question rotating the wheels, which means in organization, operational databases are very important. Data warehouse is monitoring it, which is also very important. So remember, even if we have operational, rather data warehouses, importance of operational systems will not dilute. You need to run the organization, which is what operational systems are providing us. So data warehouse is an additional thing, additional component. That to happen, wheels has to rotate. So rotating wheels is the paramount important thing in the organization. So in the next video, I will discuss with an example what's the data warehouse looks like. And thank you very much.